Okay, question number 4. This is another one of those kind of subtle concept ones that people are struggling with, or probably will struggle with, and I've already seen a question about it. What exactly is the difference between a mechanical and electromagnetic wave? So let's have a look at this. A student claps his hands once to produce a sudden loud sound that travels through the air. The sound is classified as, well, first of all, we know that sound waves are longitudinal, right, which means they travel in the same direction as the movement of particles, which should give the next part away as well, whereas transverse moves perpendicular to the direction of travel. Well, that narrows it down to 1 and 2. So basically now it's the difference between, is it a mechanical wave or is it an electromagnetic wave? Now, electromagnetic waves are very, very complex, and we're kind of just scratching the surface of them. So I don't want to get into this too much, but I want to give you what is a very basic definition of the two. A mechanical wave requires some kind of particle to travel. Right, that's a mechanical wave. Something will actually move, something physical will move. So sound waves are always mechanical because they require particles to move. Right, if I make a sound, what happens is all the air particles around me kind of absorb that sound in a longitudinal form, and then it gets to my ear, and that's how I hear it. If there's no particles, I won't hear the sound. Right, you will not hear sound in a vacuum. It's not only sound waves that are mechanical. There are some transverse waves that are mechanical. I use an example in question 1. An ocean wave, that is a transverse wave, but it's actually moving the particles of water around, right? You see that wave. Now, where it gets a little complicated is electromagnetic waves. All electromagnetic waves do is they carry energy. They do not carry physical substance. Right? So they are able to travel through a vacuum. The easiest way to think about this is, how do we see light from the sun, right? There's no particles in space. So if electromagnetic waves required particles, you would not see the light from the sun. How that actually works is quite complicated, right? It's to do with the movement of electrons at the source, creating kind of just pure energy. We have kind of talked about it in chemistry, right? When you saw that we used that reference table to talk about different colors of light. That was created by energy of electrons moving around, dropping from one level to another, right? It's just pure energy, so it does not need a particle to move. Now, that can get very, very complicated. It's very high-level physics. So I want to keep it very simple, and just to summarize, mechanical waves require physical substance, so sound waves are always mechanical. Electromagnetic waves do not require physical substance to work. They can travel through vacuums. All right, so electromagnetic waves are obviously electromagnetic. They only carry energy, not physical substance. And then sound waves are always mechanical. So the answer is 1, longitudinal mechanical wave.